Sanjay Kumar. He completed his BE Civil Engineering from Madurai Kamaraj University. He also pursued his ME Soil Mechanics and Foundation Engineering from Anna University, Chennai. He worked as a designer engineer for 1 year under a structural consultant in Madurai. He is currently working as a faculty member in the Department of Civil Engineering, Tyagarajar College of Engineering, Madurai. He has organized 2 national conferences at TCE in 2010 and 2014. He's also got 3 publications in international journals. He is an A-lead member for the Geotechnical Consultancy at Tyagarajar College of Engineering.
Welcome to UGC lecture series for architecture. Name of the subject is Mechanics of Structures 1 and we are in unit 5, which is elastic constants. This is lecture number 12. Let us see the contents for this particular lecture. We will be calculating the expression for volumetric strain of a rectangular bar subjected to 3 mutually perpendicular tensile stresses. Next, we will be seeing the definition for bulk modulus. Then we will be obtaining the relationship between bulk modulus and Young's modulus. Finally, we will be seeing an example problem for calculating volumetric strain. Now, we shall obtain the expression for the volumetric strain of a rectangular bar subjected to 3 mutually perpendicular tensile stresses. Small px is the tensile stress acting along the x axis, which is the length of the bar. Small py is the tensile stress acting along the y direction, and finally, small pz is the tensile stress acting in z direction, that is along z axis. If you see, all the 3 stresses are tensile in nature. So, px is tensile stress along x axis, py is tensile stress along y axis, and pz is once again tensile stress acting along z axis. Now, we shall calculate the strain induced along the 3 directions. The induced strain along x axis will be given by epsilon suffix x, which will be px divided by E, where px is the stress or tensile stress acting along x direction and E is the Young's modulus of elasticity, minus py divided by me. Actually, this term will be 1 by m into py by E. Py by E is the strain acting along y axis, py by E is the strain acting along y axis, which is perpendicular to the direction of x axis. Here we are calculating the total strain experienced along x axis, okay, which is the longitudinal axis. To get the strain along x axis, this strain along y axis has to be multiplied by Poisson's ratio. So, that is why here we have the term py divided by me. Negative sign indicates that because of the applied force px, the y direction will undergo contraction. Then again we have minus small pz divided by me. In the same manner, if we calculate the strain along y axis, epsilon y will be given by, now the direct stress along y axis is py, direct stress divided by Young's modulus of elasticity E minus px divided by me minus pz divided by me. Likewise, the strain along z axis epsilon z will be pz, small p suffix z divided by E minus px by E minus py by E. remember in the above three equations, that is equation for Ex, Ey and Ez, we should put positive sign for tensile stress and negative sign for compressive stress. For example, if Px and Py are compressive stresses in nature and Pz alone is tensile in nature, then Pz will be coming as positive here and Px should be substituted as minus Px here and Py should be substituted as minus Py if Px and Py are compressive in nature. Now, the volumetric strain is given by delta V by V or epsilon V is the sum of strain along the three directions epsilon x plus epsilon y plus epsilon z. So, this is the procedure for calculating volumetric strain of an object which is subjected to stresses along three mutually perpendicular directions. Now, we shall see the definition for bulk modulus. Bulk modulus is indicated by the alphabet capital K. When a body is subjected to three mutually perpendicular stresses of equal intensity, the ratio of direct stress to the corresponding volumetric strain is known as bulk modulus. So, K will be direct stress divided by volumetric strain. Now, let us consider an object in the form of a cube. If this cube is subjected to stresses in three mutually perpendicular directions and if all the stresses acting in the three directions are same or of same magnitude P. So, in this picture this cube is subjected to tensile stress intensity of small p in all the three directions x, y and z. For this case bulk modulus K will be the ratio of direct stress P to the volumetric strain. So, small p divided by delta V by V will be the bulk modulus of elasticity. Now, we shall see the relationship between bulk modulus and Young's modulus of elasticity. Once again we are going to consider the same cube. So, this cube is subjected to three mutually perpendicular tensile stresses of same magnitude along the three axes along the direction of x, y and z axis. Let the side dimension of the cube be L. Now, we shall name the corners of the cube, this corner be A and this will be B, C, D. The other four corners will be E, F, G and this corner will be H. Now, let us calculate the tensile strain experienced or tensile strain along the side AB of this particular cube. So, if you see the direction of AB is oriented towards x axis. So, strain epsilon along x axis is given by, so generally strain acting along x axis will be considered as longitudinal strain. So, which will be the ratio of change in length by original length, which will be equal to direct stress acting along x axis, which will be small p divided by E, capital E, Young's modulus of elasticity, minus the strain induced in y axis. Strain induced in y axis will be small p divided by m E minus the strain induced along z axis, which will be once again minus small p divided by m E. So, delta L by L will be equal to small p by E into 1 minus 2 by m. So, in the above equation if p by E is taken outside common, you will get this equation. Now, the original volume of the cube V will be L cube. If this equation is differentiated, we will be getting delta V, differential of L cube will be 3 L square delta L. Now, from this equation delta L is equal to L into P by E into 1 minus 2 by M. So, substituting this value of delta L here in this equation, we get delta V is equal to 3 L square into, actually this capital L is equal to small l. So, 3 L square into L into small p by Young's modulus E into 1 minus 2 by M. So, which will be once again 3 into L cube into P by E into 1 minus 2 by M. So, which is delta V. We shall take the modulus of elasticity E towards to the left hand side and we shall bring the value of delta V to the right hand side. So, we will be getting 3 L cube divided by delta V into small p by E into 1 minus 2 by M. Now, we have taken this Young's modulus of elasticity on the left hand side. So, this E will not come. So, E will be equal to 3 into L cube. L cube is the original volume of the cube. So, 3 into volume V divided by delta V into small p into 1 minus 2 by M, or 3 into p into 1 minus 2 by M, this divided by delta V divided by V. So, if we bring this volume to the denominator, we will have delta V by V here, but this term direct stress P divided by delta V by V is volumetric strain. So, direct stress P divided by this volumetric strain is our bulk modulus K. So, therefore, E will be equal to 3 into K into 1 minus 2 by M. So, this is the relationship between Young's modulus of elasticity and bulk modulus. Now, we shall see one example problem. A steel block 20 centimeter by 2 centimeter by 2 centimeter is subjected to a tensile force of 40 kilonewton in the direction of its length. Determine the change in volume if capital E equals 2.05 into 10 power 5 Newton per millimeter square. Take 1 by M, which is Poisson's ratio, equal to 0.3. So, we have a steel block, it is in the form of a rectangular block. Length of this steel block is 20 centimeter, the other two dimensions breadth 2 centimeter and thickness is also 2 centimeter. It is subjected to a tensile force of magnitude 40 kilonewton. You are asked to determine the change in volume. Change in volume is delta V. Now, delta V has to be found out. We know the expression for determining volumetric strain of an object subjected to force along one direction. Volumetric strain delta V by V will be stress small p divided by E Young's modulus into 1 minus 2 by M. Therefore, delta V is the change in volume, which will be original volume into stress divided by E into 1 minus 2 by M. In this equation, we shall substitute the things. Now, the unit for Young's modulus of elasticity is in Newton per millimeter square. So, we have to convert the applied force 40 kilonewton into Newton, and also all these dimensions should be converted into millimeters. So, volume of the bar will be 20 centimeter into 2 centimeter by 2 centimeter, centimeter into millimeter. So, 200 is the length, multiply by breadth is 20, multiply by another 20. So, this is the volume into, now we shall calculate the value of this stress. Stress P is the load by the cross section area. Cross section area perpendicular to the direction of the force. Cross section area perpendicular to the direction of force is 2 centimeter cross 2 centimeter. So, stress small p will be equal to 40 kilonewton should be converted into Newton. So, 40 into 10 power 3 divided by the area, cross section area perpendicular to the direction of force is 2 centimeter cross 2 centimeter or 20 millimeter by 20 millimeter. So, use that value here. So, 40 into 10 power 3 divided by 20 into 20 will be 400. This into 1 minus 2 by m. 1 by m is 0.3. So, 2 by m will be 0.6. So, finally, change in volume delta V will come as 15.616, the units will be in millimeter cube. To summarize the things which I have learnt in this lecture, we have seen the expression for computing the volumetric strain of a rectangular bar subjected to 3 mutually perpendicular stresses. So, the volumetric strain is given by epsilon V, which will be the sum of strain acting along the 3 axes. So, for this case volumetric strain delta V will be equal to epsilon x, that is strain acting along x direction, plus epsilon y, which is the strain acting along y direction, plus epsilon z, which is the strain acting along the z direction. Then we have seen the definition for bulk modulus. Bulk modulus is indicated by the alphabet K. Bulk modulus is the ratio of direct stress to the corresponding volumetric strain. Now, if a body is subjected to stresses along 3 mutually perpendicular directions, then we can find out this bulk modulus, which will be the ratio of applied stress, direct stress P divided by the volumetric strain. So, using this above expression for calculating this volumetric strain, we can calculate the bulk modulus. Next, we have seen a relationship between bulk modulus and Young's modulus. Relationship between bulk modulus and Young's modulus will be Young's modulus E is equal to 3 K into 1 minus 2 by m. Now, this equation will be used in order to find out the bulk modulus of elasticity of a material, provided if you know the value of Young's modulus of elasticity and its Poisson's ratio 1 by m. Then we have seen an example problem for calculating the volumetric strain and Poisson's ratio. Students can try to answer the following questions. Obtain an expression for the volumetric strain of a rectangular bar subjected to tensile stress along 3 mutually perpendicular directions. Obtain the relationship between Young's modulus and bulk modulus. Final question is a problem. A steel bar 30 centimeter long, 5 centimeter wide and 1.2 centimeter thick is subjected to an axial pull of 84 kilonewton. Determine the change in the length, breadth, thickness and volume of the bar. Take E equal to 2 into 10 power 5 Newton per mm square and 1 by m is equal to 0.32. Here you have a steel bar. Once again it is a rectangular bar. Length is given, breadth is given, length is 30 centimeter, breadth is 5 centimeter and the thickness is small t, it is also 5 centimeter. It is subjected to a pull of 84 kilonewton, axial pull, you are asked to find out the change in length. Here you are asked to find out delta L. Upon the application of this tensile force, elongation will take place. So, delta L has to be found out. Then the other two dimensions, breadth and thickness, will decrease in the breadth delta B and decrease in thickness delta T are also needed to be obtained. Finally, you have to get the value of change in volume delta V. Now, for this we can use the expression for volumetric strain of a bar subjected to force along one direction. With this we have come to the end of this lecture. Thank you.